Hello students. So in this video, let's solve problems based on speed. Okay. So problems based on speed. So far we have seen problems based on age, problems based on fractions, and problems based on two-digit number. So let's start with problems based on speed. So the first question, places A and B are 100 kilometers apart on an highway. One car starts from A and another from B at the same time. If the cars travel in the same direction at different speeds, they meet in 5 hours. If they travel towards each other, they meet in 1 hour. What are the speeds of two cars? Okay. Now, what is given in the question is there are two cases. In the first case, basically there are two places A and B. Okay. Let's say this is A and let's say this is B, and the distance between them is 100 kilometers. The distance between them is 100 kilometers. From A to B, the distance is 100 kilometer. This is first condition. Okay. So we have got two cars. Okay. One car is at A. One car is at A. Let's say this car is C1. Okay. First car, which is at A. And the other car is at B. Okay. The other car is at B. Let's say this is C2. C1 is the car 1 and C2 is car 2. Okay. Now both start at the same time. Both are going to start at the same time. And after 5 hours, and another thing is both are traveling in the same direction. Car 1 is also, let's say, going in the right side direction. Car 2 is also going in the same direction. Let's say, according to the question, after 5 hours, they are going to meet at a place. Let's say at place C. Okay. Now, if you observe, car 2 is starting from B and it is gonna go to C. Okay, so the distance traveled by car 2 is BC. Okay, this is the distance traveled by car 2, isn't it? But for car 1, it is starting at A and it is going up to C. So the distance traveled by car 1 is AC, isn't it? So with this information, let's try to form the equation. Now, distance traveled by car 1 in how many hours? 5 hours. See, it is starting at A. After 5 hours, it is going to point C. Even car 2 is starting at B. After 5 hours, it is going at C. Okay. So, distance, first let's assume the speeds of the cars. Let the speed of car 1, C1, okay, car 1 be x kilometer per hour. Let the speed of car 2 be y kilometer per hour. Okay. Now, very clearly from the figure, distance traveled by car 1 in 5 hours, that is equal to how much? It is AC, right? AC is the distance traveled by the car. Let's see, car 1 is starting at point A. After 5 hours, it is reaching destination C. Okay, so distance traveled is AC. And we also know that distance is calculated using the formula speed into time. So speed is x for car 1 and time is 5 hours. So x into 5 is 5x. Therefore, we can write this AC will be actually equal to 5x. How did we get this? Distance is equal to speed into time. Speed is x, time is 5. So x into 5 is 5x. Okay. We'll apply the same logic. Distance traveled by car 2 in 5 hours. So it is starting at B and after 5 hours it is reaching C. So therefore the distance traveled is BC. That will be equal to distance is speed into time. Here the speed of the car is y and the time taken is 5. So 5 into y. Okay, y into 5 is 5y. Therefore, the distance traveled BC, that will be equal to 5y. Okay. Now, clearly from the figure, if you observe the figure, clearly from the figure, as you can see, AB plus BC is actually equal to AC, isn't it? And what is the value of AB? 100. We have calculated the value of BC as 5y, and we have calculated the value of AC as 5x, isn't it? Now let's shift it 100 as it is, 5y to the other side. So 5x minus 5y, or I can write the other way, 5x minus 5y is equal to 100. Or if you take 5 as common, let me draw a line here. If you take 5 as common, it will become x minus y is equal to 100. Therefore, x minus y is equal to 100 by 5, which is 20. Okay, this will be our equation 1. Okay, this is scenario 1. What is the second scenario? Again, in the second scenario, we have got two places, A and B itself. The distance between them is 100 kilometer itself. And we have got two cars. Let's say car 1 and car 2. Okay, same cars. This is car 1. And let's take another car. Okay, this is car 1 and this is car 2. Now this time, both the cars are not traveling in the same direction. Car 1 is traveling in the right direction, but car 2 is traveling in the left direction, like this. Okay, obviously they're going to meet somewhere. Let's say they meet at point C. Okay, now what is the distance traveled by car 1? It is starting at A and going to C. So AC is the distance traveled by car 1. Similarly, BC is the distance traveled by car 2. In how many hours? 1 hour. The time taken is 1 hour. Excuse me. So the distance traveled by car 1, that will be equal to AC, which is speed into time. Speed is x, time is 1. So 1 into x is 1x. Similarly, distance traveled by car 2, that will be equal to BC. Again, speed into time. Speed is y, time is 1. So 1 into y is 1y. Okay. And clearly from the figure, we can see that AC plus BC is equal to AB. What is AC? 1x. What is BC? 1y. AB is equal to 100. Therefore, this will be our equation 2. So if we solve our equation 1 and 2, we'll get the answers of x and y. That is the speed of the car 1 and the car 2, which I'll leave it as a task. Easily you can do it. The value of x will be 60 and the value of y will be 40. Okay, the car 1 speed will be 60 km per hour and the car 2 speed will be 40 km per hour. So you can try it. Two equations are there, so easily you can try it. I hope you have understood this question. Let's get into the next question. Okay, in the next question, Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed of rowing in still water and the speed of the current. Okay, let's say there is a stream that is flowing in this direction. Okay, let's say this is the stream that is flowing, okay, in the downward direction. Now let's take a boat. Okay, let's take a boat like this. Okay, now what we have to find is the speed of rowing. At what speed is she rowing the boat? Okay, in still water. Remember, if the water is not flowing, if the water is still, it is not moving. Okay, if the water is still, what is the speed of the boat and what is the speed of the current? That is the speed of flowing of water. These are the two things that we have to find. Okay, now this is the boat. Now let's assume the speed of the boat in still water to be x kilometer per hour. Let the speed of rowing, let the speed of rowing in still water, that is if water is not flowing, and let's say she is rowing the boat, Ritu is rowing the boat, speed of rowing in still water, let it be x kilometer per hour. Okay, kmph, kilometer per hour. Similarly, let the speed of current, that is which speed the water is flowing, okay, let it be y kilometer per hour. Okay, now if you observe, see, these are separate speeds. Okay, y is the separate speed of the water, and x is the separate speed of the boat. Okay, if you combine them, see in the downstream, say suppose the boat is going in this direction and the water is also going in the same direction, if it is flowing in the same direction, it is obvious that the speeds will add up, isn't it? So therefore downstream speed, okay, this is the combination of the boat and the water together. Okay, downstream speed will be x plus y kilometer per hour. I hope it is clear. If the boat and the water are flowing in the same direction, then it is gonna, the speed is gonna add up, isn't it? Say suppose you are running, okay, and if someone pushes you from the back side, okay, you fall, isn't it? Because invariably your speed is gonna increase very much. So it's very obvious that if your the boat is going in the same direction, the water is flowing in the same direction, the speed will add up, isn't it? But if the boat is going in the opposite direction to the flow of water, that is upstream speed of the boat, okay, upstream speed will be x minus y, because the boat is going opposite to the flow of water. Obviously the speed will reduce, so it will be x minus y kilometer per hour. Okay, now in all the problems that is based on speed, we'll be using the time relation, most probably the time relation, that is time is equal to distance by speed. We'll use this formula. Now if you observe the question, Ritu can row downstream 20 kilometer in 2 hours, that is time taken for downstream. TD is time taken for downstream. Okay, time taken for downstream is 2 hours. So what is TD? TD is time taken for downstream, traveling downstream. Okay, so in 2 hours, the time taken is 2 hours. Okay, how do we calculate time? Distance by speed. What is the distance that she traveled in downstream? 20 kilometer. So time is distance by speed. Distance is 20. Speed, this is downstream time. So downstream speed is x plus y. Okay, equal to 2. So transpose x plus y to the other side, it will become 2 into x plus y. Now transpose 2 to the other side, it will become 20 by 2 equals x plus y. 20 by 2 is 10. Therefore, I'm sorry, 20 by 2 is 10. Therefore, x plus y, 10 equals x plus y, or x plus y equal to 10. This will be our equation 1. Now, similarly, if you observe, they have given us the time for the upstream. Time for the upstream, TU is the time for the upstream, that is also 2 hours. Okay, TU is time for upstream, that is also 2 hours. How do we calculate time? Distance by speed, that is equal to 2. What is the distance? Distance is 4 kilometer, and upstream speed is x minus y. Okay, so cross multiply, 4 is equal to 2 into x minus y. Therefore 4 by 2 is equal to x minus y. 4 by 2 is 2. 2 is equal to x minus y, or x minus y is equal to 2. Equation 2. So we have got our equation 1 and 2. If we solve by elimination method, easily we'll get the answer. So the x value will be 6 kilometer per hour and the y value will be 4 kilometer per hour. Okay, you can solve it by elimination method. So remember, in all the boat problems, this is how we take. We take the speed of the boat to be y, and the speed of the the speed of the boat to be x, and the speed of the current to be y. Now, if you combine them in the downstream, it will add up x plus y. In the upstream, it will be x minus y. And we are going to use the time relation. Okay. So let's get into the next question. So in the next question, Ruhi travels 300 km to her home, partly by train and partly by bus. She takes 4 hours if she travels 60 km by train and remaining by bus. So what is the condition given? She will take total journey of 4 hours if she is traveling 60 km by train and the remaining by bus. If she travels 100 km by train and remaining by bus, she will take 10 minutes more. Find the speed of the train and the bus separately. This is the question that we have to find. Okay. Now, let the speed of the bus be, let the speed of the bus be x kilometer per hour. Similarly, let the speed of the train be y kilometer per hour. See, if you observe the first condition, she is traveling 300 km to her home by bus and train. The total time taken to travel 300 km is 4 hours. This time is obviously divided between the train and the bus. That is, the time taken by the train journey and the time taken by the bus journey, both put together gives you 4 hours. Now, how do you calculate time, distance by speed? So for time take, t suffix t is time taken by train, time taken by train, and TB is time taken by bus. Both put together is 4 hours. What is the time taken? How do we calculate time, distance by speed? So distance traveled is 60 kilometer, isn't it? By speed is x, sorry, y, 60 by y. Okay. Plus, or let me write it like this, time taken by the bus plus time taken by the train. Okay, time taken by the train is 60 by y plus the time taken by the bus. She is traveling 60 km by train, so remaining is how much? 240 km will be by bus. So 240 by x is equal to 4. Okay, here this will be our equation 1. Okay, similarly, let's try to find the second equation. Again, the time taken by the bus plus time taken by the train is 10 minutes longer than the earlier time. Earlier it was 4 hours. So if she travels like this, she'll take 10 minutes more. So it will be 4 hour 10 minutes. But we have to convert everything into minutes. 4 hour 10 minutes. 4 hours 10 minutes. This 10 minutes, let's convert it. So 4 plus excuse me, 10 minutes into hours. So we know that 60 minutes is 1 hour. 60 minutes is 1 hour. 10 minutes is how many hours? So cross multiply, you get 10. 10 into 1 is 10 divided by this. So 10 by 60. 10 by 60 is 0, 0 gets cancelled, 1 by 6. So it is 1 by 6 hour. So if you add it, 4 plus 1 by 6, if you take LCM, it will become 25 by 6 hours. So 4 hours 10 minutes, 4 hours 10 minutes is actually equal to 25 by 6. Okay. Now, time taken by the bus. What is the distance traveled by her in the bus? It is 200 kilometers, because 100 kilometers she is traveling by train, isn't it? If she travels 100 kilometers by train and remaining by bus, remaining is 200. So 200 by x plus 100 by y is equal to 25 by 6. Okay. This will be our equation 2. Or since in the RHS, the 6 is in the denominator, what we'll do is let's multiply throughout by 6 so that the fraction will be reduced. So multiply throughout by 6. So 6 into 200 will become 1200 by x. 6 into 100 will become 600 by y. 25 into 6 by 6, 6 gets cancelled, will be left with 25. This will be our equation 2. I hope you guys know how to solve this. This is not a linear equation. You have to reduce it to the linear equation. As you know, 240 by x can be written as 240 into 1 by x, and 60 by y can be written as 60 into 1 by y is equal to 4. Similarly, 1200 by x can be written as 1200 into 1 by x plus 600 into 1 by y is equal to 25. Okay, so put 1 by x as u, put 1 by x as u, and 1 by y as v. Okay, so therefore it will become 240 u plus 60 v is equal to 4. 1200 u plus 600 v is equal to 25. Let's solve for v because it is very easy. The LCM of 60 and 600 is 600 itself. So I have to just multiply this by 10. So it's very easy. So it will become 2400 u plus 600 v equals 400. 1200 u plus 600 v equals 25. Actually, you can also take common and solve it. It's very easy. So let's change the sign since they are same. Plus 600 minus 600 gets cancelled. 2400 minus 1200 is 1200 u equals 400 minus 25. It becomes 375. Okay. Therefore, u becomes 375 by 1200. Okay, let's see, 375 into 4. Will it give us 1228? 4 3s are 12. It gives 1400. Okay. Okay, there is some mistake. Yeah, I got it. 4 into 10 is 40. Actually, I made a mistake here. So 40 minus this is, we get 15. So it will become 15 by 1200. So 15 ones are 15 eights are 0. Therefore, u is 1 by 80. So if u is 1 by 80, x will become 80. So 80 kilometer per hour. That will be the speed of x. That is the bus. Similarly, substitute the value of u in any one of the equation, you will get the value of v. Let me do it here. Let me take the first equation. 240 u plus 60 v is equal to 4. So 240 u is 1 by 80 plus 60 v equals 4. So 81s are 83s are. So transpose 3 to the other side. 60 v is equal to 4 minus 3. Therefore 60 v is equal to 1, which implies v is 1 over 60. If v is 1 over 60, y will become 60. Okay, the speed of the train will become 60 kilometer per hour. So remember, whichever problem is based on speed, we are going to use the time relation. That is, time is equal to distance by speed. Using this logic, we are going to get the equations, required equations. I hope you guys have understood this. So in the next video, we'll start with problems based on statement problems based on cost. Okay. Thank you, students.